we're going to continue talking about periodic trends now. Specifically, we're going to hit ionization energy. So, to begin with, you need to be aware that metals tend to give electrons away. Nonmetals, they will take those electrons. This way, both the metals and the nonmetals can complete their valence shell. Well, one way that we can, one thing that we can measure is the amount of energy that's necessary to take away that ion, okay, so or to take away the electron and form the ion. So this energy we call ionization energy, and we have a table here that shows some of those values. So you notice going from left to right, 403, 549, 600, 640, 652, you see that the general trend is an increase in energy, which means it takes more energy, okay, so it takes a lot of energy, this value is high, it takes a lot of energy to remove electrons from our nonmetals. It doesn't take as much, so it's a lower ionization energy to take away from metals, which should make sense because the idea behind this is what we really care about is metals want to give away electrons, nonmetals want to take. Okay, so it should take very low energy, very little energy to remove the electrons from metals, especially these very reactive metals. Now going from top to bottom, notice our values here, 1312, 520, 495, 418, 403. These values are going down. So the increasing trend here goes from the bottom to top, ionization energy increases. If we combine that, we get a vertical, or I should say diagonal line. Ionization energy will increase from bottom left up to the top right. Now, unlike electronegativity, these will go all the way through, all the way up to these noble gases. Notice the noble gases really don't want to have an electron removed. They've got very, very high values, 2300, 2000, 1500, right, compared to 380, 375, right, much smaller numbers there on the left. So now let's go ahead and work some practice problems here. I'll give you guys a second. You can go ahead and pause, and then we will get into it here. So I will assume you've paused, and we'll look here. Number one, order the following elements in terms of increasing ionization energy. So increasing ionization energy, we are looking at low values to high values. And let me go ahead and throw on the highlighter. So we want to go low to high. Sodium, sulfur, argon, and aluminum. So I've got sodium, and let's see, there's my sulfur, argon here, and aluminum. So sodium, sulfur, argon, aluminum. If I want increasing ionization energy, I want to go low to high values. And you'll recall that the lowest, bottom left, the highest values are top right. So I want low to high, I want left to right. Sodium, and then aluminum, then sulfur, and finally argon, if I put those in order. Now order the following elements in terms of decreasing ionization energy. So this time I want to go high values to low values. We want this to be decreasing. Okay, so let's go ahead and let's erase that ink. It's going to be high to low, and we'll highlight these again. It's calcium, barium, magnesium, radon. So calcium, barium, magnesium, and radon. So looking at these values, we want to go from high to low. So this time, high values are on the top right, low values bottom left. Top to bottom, I want to go high to low, top to bottom. So it will be magnesium, calcium, barium, and lastly, radon. Okay, now order the following elements in terms of decreasing. So again, decreasing is going to be high to low. And we are looking at iron, zinc, rubidium, silicon. So iron, and let's see, it was rubidium, not zinc, zirconium, Zr, and then lastly silicon here. So we want decreasing high to low, so high values are top right, low values bottom left. I want to go silicon, iron, zirconium, rubidium. Okay, now go ahead and erase that again. So lastly, I want increasing ionization energy. So this one is going to be, again, low to high values. And we're looking at helium, copper, francium, and carbon. So if I want low to high, I'm going to begin here with my francium, copper, carbon, and finish with helium.